Hello students, welcome to Darasa Online. My name is Josia Mwakitalima. I'm teaching chemistry. So I'm here with you to discuss some issues or concepts that are challenging most of the students. So listen to it and make a follow-up from the beginning up to the end of the lesson. So our topic today is about nonmetals and their compounds. Specifically in this topic, for this lesson, we are going to discuss the subtopic known as sulfur dioxide. So by the end of this lesson, I'm sure each of you will be able to discuss about the chemical properties of sulfur dioxide, and also uses and hazards of sulfur dioxide. So these are the main issues that you need to concentrate when studying this subtopic. And specifically on the chemical properties of sulfur dioxide, here we'll discuss about the reducing properties of sulfur dioxide. We'll also discuss about the bleaching property of sulfur dioxide. We'll also discuss about the oxidizing property of sulfur dioxide. So these are the issues that we are going to discuss or concentrate on this subtopic. So now let us start our discussion by talking about what is sulfur dioxide. Sulfur dioxide is a binary compound of sulfur with oxygen. So this one is a binary. It's a binary compound of sulfur with oxygen. And it is represented by a formula. It is represented by capital letter S, capital letter O with sub 2 there. And sometimes we call it as sulfur 4 oxide. So it is also known as sulfur 4 oxide. And this compound exists in gaseous state, so it is a gas. And that kind of gas, its effect is very, very poisonous gas. It's a very poisonous gas. So after this introduction, now let us go to how can you prepare sulfur dioxide in the laboratory, which means that in the preparation of sulfur dioxide. Now, laboratory preparation of sulfur dioxide is by reacting any sulfite or hydrogen sulfite with concentrated sulfuric acid. So the preparation is done by using or by reacting a sulfite or by hydrogen sulfite or hydrogen sulfite with an acid. And how does the process take place? Now let us see the setup experiment on how you can do during preparation of sulfur dioxide. Here now is the diagram showing how can you prepare sulfur dioxide in the laboratory. As what I have said, that you need to have sulfite, and here I have used the sodium sulfite or N bisulfite, which means that it can be sodium bisulfite or potassium bisulfite. And you need also to have dilute hydrochloric acid or a dilute acid. So when a dilute hydrochloric acid is allowed now to drop into the round bottomed flask where there is a sulfite, now a chemical reaction starts to take place. And that chemical reaction, since here we have taken sodium sulfite and dilute hydrochloric acid, so you can see the reaction behind here. So the reaction taking place, is that you have sodium sulfite, then reacting with dilute hydrochloric acid. Then the product here will be sodium chloride as an aqueous. Then we are going to have sulfur dioxide gas and the water. So this is a reaction representing the reaction between sodium sulfite and the hydrochloric acid. So here we see we have the sulfur dioxide gas which is released. Now you can balance the equation. It's your task to balance it. So the sulfur dioxide that will be produced now will be escaping through this delivery tube. So it will be now passing through that, then into the flask containing concentrated sulfuric acid. So you can ask yourself, why sulfuric acid here? Sulfuric acid here acts as the sulfuric acid here acts as a drying agent, since if sulfur dioxide needed in dry form. So when it enter into sulfuric acid, if there is any water inside the sulfur dioxide, now will be dried by concentrated sulfuric acid, and then from there the sulfur dioxide will start escaping into the gas jar. Now do we see here the method of collecting sulfur dioxide is downward delivery method. So you can ask yourself, why downward delivery method? Because sulfur dioxide is denser than air. So that is how you can prepare sulfur dioxide in the laboratory. But if you don't need a dry sulfur dioxide, there is no need of passing it through the concentrated sulfuric acid. So you can just pass it directly or collect it directly into the gas jar and have that sulfur dioxide gas. So from there now you'll have prepared sulfur dioxide gas. So it is a reaction between a dilute acid with hydrogen sulfide or N sulfite. So the sulfur dioxide, which is now formed here, is what we have said is a poisonous gas. So if it is a poisonous gas, that means the process of preparing it should be done in a special room known as fume chamber. So you cannot prepare sulfur dioxide in an open place, so it must be prepared in a fume chamber. From that preparation now, let us go and consider or discuss the properties of sulfur dioxide. So we have the chemical properties of sulfur dioxide gas. So let us start discussing about the reducing property. Reducing property. So sulfur dioxide are good reducing agents. How is when they react with any other oxidizing agents. So their cells get oxidized, but the oxidizing agent get reduced. So here is that sulfur dioxide gas, when reacted with any oxidizing agent, here taking an example of potassium permanganate and the potassium dichromate. These are very common oxidizing agents used in the laboratory. So sulfur dioxide get reduced, get oxidized, while the oxidizing agents is reduced. So it is a kind of redox reaction. So let us see now the reactions of sulfur dioxide gas with the oxidizing agents. So the first reaction, let us consider the reaction between sulfur dioxide gas with potassium permanganate. So here we have potassium permanganate as an oxidizing agent that reacts with sulfur dioxide, but in presence of water, which is a liquid. This is gas, and this is an aqueous. The product obtained here, you'll have potassium sulfate, then plus manganese sulfate and the sulfuric acid. So you can balance the equation, is your task to balance. So do you see here, potassium permanganate in color is purple, get reduced to colorless of manganese to sulfate. So this becomes colorless. So potassium permanganate get decolorized by sulfur dioxide gas. So what does it mean here is that permanganate here have an oxidation state of positive 7. The manganese in this compound have an oxidation state of positive 7, But manganese, this one, have an oxidation state of positive 2. Have an oxidation state of positive 2. So do you see there is a decrease in oxidation number? And the decrease in oxidation number, it is reduction. That's why I have said that the oxidizing agents get reduced, but the reducing agents get oxidized. So sulfur dioxide is oxidized, but the potassium permanganate is reduced. And the reduction of potassium permanganate is accompanied with color changes, whereby the purple color disappear. So the solution becomes what? Becomes colorless due to formation of manganese sulfate. That is about the reaction of sulfur dioxide with the potassium permanganate. We can consider also the reaction of potassium dichromate. This is potassium dichromate. When it reacts with the sulfur dioxide, but it must be acidified potassium dichromate. Acidification, we add sulfuric acid. So sulfuric acid here is for acidification of potassium dichromate. So what will be the product here now? The product here will be potassium sulfate, and the other product will be chromium 3 sulfate. Chromium 3 sulfate is this one. So here must be 3 and here must be 2. And the other product is water. So water get also released during the reaction. So this is an aqueous, this is an aqueous, and this is an aqueous also. This is a gas, and this is an aqueous. You can balance the equation, so it's your task. But what is being observed in this reaction is that the potassium dichromate is orange in color, but the chromium sulfate is green. So there is a change in color during the reaction from orange to green. And what green color represents? Green color is due to presence of chromium 3 ions, which is green, and this is what makes the compound. So it is due to formation of chromium sulfate. So do you see now how sulfur dioxide acts as an oxidizing agent? So let us see now another reaction in which sulfur dioxide acts as a reducing agent. So sulfur dioxide acts also as a reducing agent in the following reactions. As a reducing agent in the reaction between reaction with the iron 3 sulfate. So in this reaction, sulfur dioxide reduces iron 3 sulfate into iron 2 sulfate. So here, the reaction behind is that iron 3 sulfate is this one. This is iron 3 sulfate. So when it treated, this is an aqueous. So when it treated with the sulfur dioxide, but in presence of water, the product formed will be iron 2 sulfate as an aqueous, then plus sulfuric acid. So this is the reaction behind. Now, if we write the ionic equation, you'll end up getting, this is iron 3, get reduced to iron 2. So this is iron 2. And also there is a change in color here. Since iron 3 is brown in color, then it leads into formation of pale green color of iron 2. So that is how now the sulfur dioxide acts as a reducing agent. So once it comes into contact with any oxidizing agents, it becomes oxidized, but the oxidizing agents becomes reduced. But in solution, here where we were talking about the reaction between potassium permanganate and sulfur dioxide, if it is in aqueous solution, sulfur dioxide here acts as bleaching agent, which means that it is used in removing, so it can remove oxygen from dyes and form a colorless compound, and it is used in bleaching fibers. So that is one of the application we will see on the application of sulfur dioxide. So it is used as bleaching agent. So that is in case of oxidizing property. So let us consider another property of sulfur dioxide, which is as an oxidizing agent. So apart from what we have talked here, that it is a reducing agent, but sulfur dioxide also it can act as an oxidizing agent. So as sulfur dioxide as an oxidizing agent, and here we are going to consider the reaction of sulfur dioxide and the hydrogen sulfide gas. So here is that hydrogen sulfide gas become reduced since sulfur dioxide is an oxidizing agent, itself becomes reduced, but hydrogen sulfide becomes oxidized. So hydrogen sulfide gas become oxidized into sulfur, while sulfur dioxide gas becomes reduced into water formation. So what is happening here is that if you have hydrogen sulfide and treated, if you have hydrogen sulfide and treated with sulfur dioxide gas, the product that you'll have is sulfur and then plus water molecules as a liquid. And sulfur here is solid. So here there is an observation that can be observed through your eyes. And that observation is due to formation of yellow precipitate of sulfur. So sulfur here appear as yellow precipitate. So that is now how sulfur dioxide can act as an oxidizing agent. So it oxidizes hydrogen sulfide by removing hydrogen to sulfur, which is yellow in color. So from there now, let us go and discuss. If now you have been given sulfur dioxide, normally sulfur dioxide is colorless and odorless. So if you have been given a gas which is sulfur dioxide, how can you identify that it is sulfur dioxide? So we have a chemical test. Chemical test for sulfur dioxide gas. The sulfur dioxide gas in the laboratory can be tested by using a filter paper, with the potassium dichromate. A filter paper with potassium dichromate. That means when a filter paper is soaked, here when a filter paper is soaked with the potassium dichromate, so what will be happening here is that the orange color of a filter paper that is soaked into potassium dichromate change into green color. From there now, it means that sulfur dioxide have reacted with the potassium dichromate, which now were soaked with the filter paper. So the filter paper turn into green color. And the reaction behind is that potassium dichromate is an aqueous which is orange in color. When it reacts with sulfur dioxide, here the reaction must be under acidic condition because it is a redox reaction. So the acid used in acidification is sulfuric acid. So here then you will get chromate sulfate and the other products that are being formed. So you can complete that reaction. But what I'm telling you here is that the orange color now of chromate is this one, which is orange in color, so change into green color. The green color is due to presence of chromium 3 ions. So chromium sulfate now becomes green in color. So that is how sulfur dioxide can be tested in the laboratory. Now let us consider the uses of sulfur dioxide. We have uses of sulfur dioxide. Sulfur dioxide is used in the manufacture of sulfuric acid in a process known as contact process. So manufacture of sulfuric acid. In a process known as contact process. Normally, sulfur dioxide gas is acidic. So when dissolved in water, due to its high solubility, it dissolves in water to form sulfurous acid. And later on, the sulfurous acid, when sulfur dioxide is next, then will form what we call it sulfuric acid. So I'm sure you know what is sulfuric acid because we are using it in different practicals in a chemistry laboratory. And also not only in chemistry laboratory, even in biology laboratory, sulfuric acid is also used. Now, the second application or uses of sulfur dioxide is as a bleaching agent of fibers. And here mainly animal fibers which are of animal origin. So they are being bleached or converted into white color, those fibers, by using sulfur dioxide gas. Another uses of sulfur dioxide is that it is used in manufacture of calcium hydrogen sulfite. Normally, calcium hydrogen sulfite is a bleaching agent. So calcium hydrogen sulfite is a bleaching agent. So is used in bleaching wood pulp, in making papers. So papers are white because they have been bleached by calcium hydrogen sulfite. So it is the application of sulfur dioxide that results into formation of that compound which is known as calcium hydrogen sulfite. But not only that, sulfur dioxide is also used in fumigation, in fumigating houses and the clothes. Here, since we have said that it is poisonous, fumigating houses and clothes here so as to kill microorganisms and insects. So that is another uses of sulfur dioxide gas. Apart from that, the liquid sulfur dioxide is used as a refrigerant in refrigerator. And this is due to its cooling process that it takes place at very, very low pressure. So that is why we use it as refrigerant in refrigerators. But from there now we have the hazards of sulfur dioxide. In hazards of sulfur dioxide is that sulfur dioxide is the main air pollutant gas. So sulfur dioxide is the major air pollutant. And the sources of sulfur dioxide, the main sources of sulfur dioxide is from power plant, power plant that uses fossil fuels fossil fuels such as coal and diesel. So this results into emission of sulfur dioxide into the atmosphere. But also here we have the sulfur dioxide from exhaust motor vehicles. They also emit sulfur dioxide into the atmosphere. And as we know that since it's a major air pollutant, it results into affecting the respiratory system, and sometimes it may cause death if it is present in excess. So another hazards of sulfur dioxide is that it results into formation of acidic rain. Acidic rain. Since we know that when sulfur dioxide is released, it is released into the atmosphere, and in the atmosphere during raining, the rain now combine with sulfur dioxide and resulting into formation of sulfuric acid. And that sulfuric acid are being, when come into seas or rivers or oceans, is where now it can kill. So it kills now here, it can kill the egg fish. So if it kills the egg fish, that means even those organisms that are depending on eating egg fish or eating fish, because even fish, the egg fish or making fish ill, so here is that even those organisms now that are depending on fish may also get ill. For example, we have bees. So once bees eat a fish which is ill due to the acidic rain, as what I have said here, the acidic rain is due to presence of whereby the sulfur dioxide reacts with water, and water is rainwater from the atmosphere, then from the sulfuric acid which is now released into those sources of water where different living organisms are present. But also acidic rain may affect plants. Various plants may get dried due to presence of acidic rain. So my dear students, from this what we have discussed is all about sulfur dioxide. So that is how sulfur dioxide can affect the life of living organism. So from there now, I'm sure you have enjoyed the lesson. So let us now go and discuss some questions that needs you to use the knowledge that we have discussed in answering them. So that an aqueous solution of sulfur 4 oxide reacts with the hydrogen peroxide and the hydrogen sulfide according to the following equation. Equation number 1 is about the reaction between hydrogen peroxide and sulfur dioxide to form water and the sulfuric acid. The second equation is between hydrogen sulfide and sulfur dioxide to form water and the sulfur. So my dear students, the question is, explain in which reaction sulfur 4 oxide is an oxidizing agent and in which equation sulfur 4 dioxide is a reducing agent. So I'm sure you remember the reactions when we were talking about the discussion between sulfur, the discussion on the chemical properties of sulfur dioxide as an oxidizing agent as well as a reducing agent. So in the first equation, it is a reaction between sulfur dioxide and hydrogen sulfide. So if we calculate the oxidation state of sulfur in sulfur dioxide and the oxidation state of sulfur in sulfuric acid, we will see that there is an increase in oxidation state from positive 4 to positive 4 in sulfur dioxide to positive 6 in sulfuric acid. So do you see here that there is an increase in oxidation state? So here it is a reducing agent, because any substance which get oxidized during the reaction is a reducing agent. So here sulfur dioxide is a reducing agent. If we consider part B, between hydrogen sulfide and sulfur dioxide, here sulfur dioxide is an oxidizing agent because it is reduced. Since a solid substance have an oxidation state of 0, so sulfur dioxide, sulfur here in sulfur dioxide have an oxidation state of 4. And here sulfur as a solid has an oxidation state of 0. So there is a decrease in oxidation number. So here sulfur dioxide acts as an oxidizing agent. So in part B, sulfur dioxide is an oxidizing agent. Why? Because it has changed from oxidation state of positive 4 in sulfur dioxide to oxidation state of 0 in sulfur, which is solid. So that is about how you were supposed to answer such kind of question. So my dear students, let us go and consider question number 2. Question number 2 is that one. And the question is that in an experiment set to prepare sulfur dioxide, a student poured a dilute sulfuric acid through a thistle funnel into sodium sulfite in a flat-bottomed flask. When the resulted mixture was heated gently, a gas was evolved and was passed through a concentrated sulfuric acid, then corrected by downward delivery method. A piece of paper was soaked in an acidified potassium dichromate and held at the mouth of the gas jar, and the lid was replaced. The question is, what will happen to the piece of paper? A piece of paper was soaked in a solution of potassium dichromate. So which means that potassium dichromate, I'm sure you remember that potassium dichromate is orange in color, but the sulfur dioxide is passed through a piece of paper having potassium dichromate. Do you remember the chemical test for sulfur dioxide? We have said that it changes an orange color of potassium dichromate into green color. This is a redox reaction whereby sulfur dioxide acts as a reducing agent and the potassium dichromate acts as an oxidizing agent. So you can write those explanations that I'm telling you. So what will happen to the piece of paper? A piece of paper will turn from orange into green color due to formation of chromium 3 ions. So that is about question number 2. Question number 3, part B, is that what was the purpose of placing a piece of paper soaked in the acidified potassium dichromate at the mouth of the gas? The purpose of putting a piece of paper at the mouth of the gas jar. Here it means that if this is a gas jar, then the mouth of gas jar is there. Then a piece of paper is placed here. That means we are testing if the gas is full in a gas jar. Because if the gas is full in a gas jar, and you have said that here sulfur dioxide is denser than air, so it will start filling the bottom part up to the upper part. So once it reaches at the upper part, it will change the green color of the paper, the orange color of the paper into green color, showing that it is now full in the gas jar. So that is about part B. Now we have part C, that why concentrated sulfuric acid is used in this experiment. Do you remember about the preparation of sulfur dioxide? We said that sulfuric acid, concentrated sulfuric acid, is used as a drying agent. So in this experiment, it was used as a drying agent. But part D is that why the gas was collected by downward delivery method. Downward delivery method is a method specifically for all gases which are denser than air. So sulfur dioxide is denser than air. That's why we use downward delivery method to collect it. From there now, my dear students, this question number 4 is your assignment. So it's your task now to do it. And I'm going to read for you, so you have to copy it. Now, the question is, comment on the following observations. A, when a blue litmus paper is dipped in a test tube containing sulfur 4 oxide, its color changes to red, then bleaches. B is that a white precipitate forms when concentrated nitric acid is added to a test tube full of sulfur 4 oxide, then followed by barium sulfate. So these are questions as an assignment. So please do it, and you can consult for correctness through your number that will be passing through the TV. From there now, we have the references. These are references that you can use to find the answers or more knowledge on the matter that we have discussed here. The first reference is Chemistry for Secondary School, Book 2 by Tai of 1995. But also we have the second reference, which is known as Chemistry for Secondary School Form 4, and is of Oxford University. But also we have the third reference, which is known as a new certificate chemistry, 4th edition, commonly known as Lambert. And through these references, I'm sure you will be able to answer those questions, or you will be able to answer any examinations after reading it. So my dear students, I'm sure you have enjoyed the lesson. So this is my end of presentation. Keep on following us on Darasa Online. Thank you very much. Goodbye.